Good morning, all of you. So now today we are going to discuss about the reducible to exact differential equation. Means the given differential equation or first order, first degree differential equation is not an exact form. So to make it an exact, then we will introduce a integrating factor. Every differential equation has more than one integrating factor. So before you have to know the what is integrating factor. Integrating factor first. Integrating factor if m of or m dx or m of x comma y into dx plus here n into dy is equal to 0 is not exact, then it can always be made exact by multiplying some functions of x into y is called integrating factor. Then there is no general method for finding an integrating factor. There are infinite integrating factor of this given first order first degree differential equation. Remind here, every differential equation of first order first degree always exact differential equation. Sometimes it may not exact. To make it an exact differential equation, we should multiplying some functions of here x into y is called integrating factor. So first problem, first method, rule 2, rule 1 is inspection. So rule 2 is, so what is the procedure we have? First different step 1 here also is same. Step 1 is given differential equation is comparing with m into dx plus n into dy. Here we will get here m into n. And in step 2, we will find out dou m by dou y and here dou n by dou x. In step 3, dou m by dou y is not equal to dou n by dou x. If dou m by dou y not equal to dou n by dou x, the given differential equation is not an exact. So then we observe the differential equation. Here rule 2. Rule 2 is given differential equation is homogeneous. The given differential equation is a homogeneous. Take an integrating factor is equals to 1 by mx plus here n into y. Means if the given differential equation is homogeneous, integrating factor m 1 by mx plus ny. So to make it an exact, this integrating factor is multiplying to equation 1. Means here equation 1 is multiplying by integrating factor. So then 1 by mx plus here ny of m into dx next plus here n into dy is equal to 0 is exact differential equation. So after multiplying to mx plus ny, we'll get in the form here m1 dx plus here n1 into dy is equal to 0 is exact. Is exact means dou m1 by dou y, dou m1 by dou y is equal to dou n1 by dou x. Okay, so this is what here, this equation 2 is an exact differential equation. So the general solution is integration of m1 into dx next place here integration of here n1 into dy is equals to c. Means here which do not contain x terms, which do not contain x terms in n. Means we should take only y terms. Okay, when we will take this integrating factor as 1 by mx plus ny, the given differential equation is homogeneous. If not homogeneous, what do we take an integrating factor? Yes, go to the rule 2. The given differential equation is, this is a rule 3. Given differential equation is not homogeneous, not homogeneous, but in the form, of y into f of x comma y into dx. Next place here x into g of here x comma y into dy is equal to 0. We take an integrating factor is equals to 1 by mx minus n into y. Given differential equation is nothing but m into dx plus here n dy is equal to 0. This is an equation 1. It's not an exact, not homogeneous, but in the form of f of y into f of x comma y into dx plus x into g of x comma y into dy is equals to 0. This integrating factor is 1 by mx minus ny. The given differential equation, to make it an exact, this integrating equation 1 is multiplying by integrating factor. Yes, so then we will get m1 into dx, next place here n1 into dy is equal to 0. So this is the exact differential equation of first degree first order. Means now dou m1 by dou y is equal to dou n1 by dou x. So then the general solution is same. Integration of here m1 into dx, next place integration of here n1 into dy is equals to c. Means here we should take only y terms on n1. We don't take x terms in n1. Okay. Yes, the given differential equation is not exact but homogeneous. Go to the rule 2. With the not exact, not homogeneous, but in the form of y of x comma y into dx plus x of g of x comma y into dy is equal to 0. Now it is said to be, means take as integrating factor is equal to 1 by mx minus ny. So next one, the given differential equation is not exact, not homogeneous, and not in the form. How do we take here? Rule 4. Rule 4 is here given, means here m into dx plus here n into dy is equal to 0 is not exact, not homogeneous, not exact, not homogeneous, and not in the form, not in the form of y into f of x comma y into dx. Next place here x into g of here x comma y into dy is equal to 0. Here we take an integrating factor. Two cases will be taken here. First one is here integrating factor if is equal to e power integration of here f of x into dx. Now this is the case 1. Next here case 2, integrating factor is equal to e power integration of here g of y into dy. Here where f of x is equals to 1 by n of dou m by dou y minus dou n by dou x. This f of x means the function of x alone or constants. Or constants. Next, where here g of y, where g of y is equals to 1 by m of dou n by dou x minus here dou m by dou y. We get function of y alone or constants. Sometimes the function contains y terms. This first case will be failed. Go to the next case. Okay. If it will be failed, come to this one. If the both or not exist, not satisfied, then the given differential equation may in linear or may in Bernoulli differential equations. Okay. Now solve one problem. Solve y of here x square y square plus here 2 of dx. Next place here x into 2 minus 2x square y square of your dy is equals to 0. Solve the differential equation. So first, this equation is comparing with m into dx plus n into dy is equal to 0. We get here m and n. Now here m is equal to y of your x square y square plus 2. And what about here n? X of 2 minus here 2 x square y square. Okay, now I've been compared with m into dx. Next place here n into dy is equal to 0. Now in coefficient of dx is m. Now here m is equal to. So this is what here n. Now find out dou m by dou y and dou n by dou x. Before that, now multiply here. Y into x square y square. You will get here x square into y cube plus here 2y. Now this 2x minus 2x power 3 into y square. So dou m by dou y means here dou by dou y of here m. So here dou by dou y of m. M is equal to x square y cube plus here 2y. Next, find out here dou n by dou x. So here dou by dou x of here n. Now here dou by dou x of n. N is equals to 2x minus here 2x cube y square. So here differentiating with respect to y. So we get x square as a constant. So derivative of y cube 3y square. Next plus 2 into 1. So we get 3x square y square plus 2. Dou by dou x of 2x here it is 2 minus. So 2 in derivative of x cube 3x square into y square. So we get here 2 minus 6x square y square. So therefore dou m by dou y is not equal to dou n by dou x. Given differential equation is not an exact. Given differential equation is not an exact differential equation. Now observe the given differential equation is homogeneous or non-homogeneous. See here, homogeneous means each and every term degree should be same. Okay. Now when I multiply to here, what will happen here? Now y. So here x square y power 3 plus here 2 y of here dx, right? Now we are x power 2 plus 3 5 y power 1 is not equal, not homogeneous, but is in the form of y into f of x comma y into dx. Next place here x into g of here x comma y into dy is equal to 0. Yes, now this is in the form of this one. So take an integrating factor is integrating factor 1 by mx minus ny. So if is equal to 1 by mx minus ny.